thanks to Jeremy for inviting me.
Yeah, and thanks to Brendan for jumping in at the last minute and pulling this together. And it looks like we have a full house, which is great because I know it's been a long 2 days of full-time JavaScript. If this was the real Oregon Trail, right, y'all would have been eating squirrel meat for 3 weeks by now, and a few of you would have sprained ankles. We'd probably be facing the rapids at this point. So thanks for holding through. I want to talk about, me and Brendan want to talk about the next upcoming versions of JavaScript and little languages like CoffeeScript and U. Because, you know, it's always fun to attend a JSConf to get the truism out of the way up front. JavaScript is in the middle of a huge renaissance, right? The economy might be in the dump, your rent might be too damn high, but at JSConf, you know, the sun is always shining. We have real browser competition now. We have new HTML5 APIs where HTML5 is really code for taking JavaScript seriously, and we have Node. But the JavaScript renaissance requires your participation. And we're now at a stage where after being stuck, you know, in the sands of time for nearly a decade, JavaScript, the language, is starting to become unfrozen, starting to change. So we have Harmony, and we have JS.next, ES.next, whatever you want to call it, future versions of the language that we all use. And so where ECMAScript 5 was a very important but relatively minor step forward, Harmony might prove to be the real next version of JavaScript. And big things are afoot. Both in the currently accepted harmonious proposals as well as the more developmental strawman proposals, if you check out the Harmony wiki. And Brendan Ike talked at last year's JSConf in DC about some of the things that were going on with Harmony. And so instead of me talking about it, there's no better man than the man himself to...
Thanks, Jeremy. We're going to trade again, so I'll be as quick as I can. I like to start with these quotes. I've been warming up Mozilla crowds with them. It always pays to channel Sarah Connor. And you know, I think developers do fear the future because they fear some standards bodies or some browser vendors are just going to mess with you and you have no say in the matter. But that's not true. With browser competition and a pretty balanced market, the browser vendors want developers to like them. And developers can say what browser vendors have to do to be liked. So you have power, you should use it. You should help invent the future. Something I think a lot of people have said, there's an epigram that is attributed to Alan Kay about the best way to predict the future is to invent it. And that's happening. You don't even have to wait for the ECMA committee. Jeremy didn't, and look how that's going. It's great. I talked yesterday, and Dave Herman showed this morning what can be done if you're willing to do some work in JavaScript to handle new languages or new language forms. And the important thing is to not only do this, but learn from it and feed that back through the community, through the code culture, and into the ECMA committee, where I'm one of the people who wants to carry it, and carry the committee, kicking and screaming if necessary. So let's review the Harmony goals. This strange tradition of Harmony was created in the aftermath of the failure of the 4th edition of ECMAScript in 2008 in the summer, and we agreed on enough fundamental sort of value in the language and in the history of languages, like lexical scope, that we threw together some goals. And they include things like being a better language for writing complex applications. People are doing that now. Also libraries, including the DOM, which should be just another library that you can hack. And we're working on that at Mozilla with a proxy-based implementation. And being a good target for code generators. That is obviously something of interest here with CoffeeScript, with Jeremy. It's also being done all over the place. There's all sorts of languages. There's, my favorite example is Sculpt, a Python to JavaScript translator. And this testing thing is going to be tricky. We don't know if we can actually have any kind of executable specification anytime soon, but we have better test suites, and that's the important thing. We want to adopt de facto standards. I think most in the committee agree with this. Occasionally we have to do a little bit of committee polishing or smoothing out, but we really don't want to be coming up with library code or better APIs or even necessarily better syntax ideas. We want them to come from the users. So we fight for the users. Versioning is something I'm not going to talk about, but it's on our minds. We don't want to make a big version tree that branches and branches again. We want a very simple linear structure. And this last one is of interest to certain people on the committee who have been very valuable in their work, and we value their contributions. And we think security does matter, and fundamentally JavaScript is a capability language underneath layers of bugs and DOM mistakes and other things. So let me talk about what is already going into Harmony. Sometimes this comes up as a question. I can't tell what's being proposed and what's just sort of being thrown up as an idea and what's actually going to be in the next edition. And you can't be sure until the next edition is written down and nearly done, but it's looking good for let constant function as block-scoped declarative forms, when you put function inside curly braces, that is to say. Right now, that is an extension to all the existing standards that browsers implement differently. A lot of them follow IE. We do something different in Mozilla code, Rhino and SpiderMonkey and Firefox. We're going to standardize function inside a braced block along with let and const as binding a block scope name, function hoists to the top of the block. This gives you better var and better control over what you want. We already have destructuring in SpiderMonkey and Rhino. I think Opera has support for destructuring, possibly in all the forms. It's extremely convenient. You recognize from other languages, Python, ML. It's awesome. Parameter default values, you want those instead of having to write arguments tests, argument length tests. Rest and spread, these are quite popular. Not implemented yet, but people can see where this is going. They want to stop using the arguments object and start using a real array that captures all the trailing arguments to a function. And if you can do that, then you can also turn around and take an array and splat it out as positional parameters in a call expression. And that's what the spread operator or spread special form does, that ... a at the bottom. They're complementary. This, over time, should eliminate the arguments object, which has been a source of pain for many people. And modules, Dave talked about, not much more to say there. Modules are overdue, and I think they'll really help code sharing and code reuse, and people are already enjoying them in the CommonJS forum, especially on Node, where you can have require processed synchronously, but the client side needs them too, and it needs them in this way that's been proposed. Iterators and generators, believe it or not, are harmonious. There are some details to work out, but the idea is that you'll have something very much like Python's generators. And if you look closely at that bottom line, you'll see a star after the function keyword. That is a very fresh idea for me that probably will be needed to get the committee to buy into this, because it allows you to say up front at the head of the function that it is a generator function. You don't have to look in the body to see a yield and realize that it's quite different from an ordinary function. The star at the front means it's a generator. You can also make an empty generator, which happens to matter. And comprehensions, this is something obviously in CoffeeScript and Python, Ruby, all good languages have them. Haskell ML, you really want these things. They're much more convenient than writing a push loop, and you can also change the square brackets to parens to have a generator expression, which is a very convenient way of writing a generator function that is immediately applied. Okay, so what else is coming in ES Next? This is also harmonious, believe it or not. I mentioned this in reply in comment to David Flanagan's talk on the first day. Binary data is an embrace and extend operation on typed arrays from the WebGL Chronos group. Typed arrays are in a lot of browsers. They're awesome with WebGL. They give us good access to bits and bytes and uint32s in a row in memory. You need that not only for WebGL, but for the file API and all the new web APIs that are coming along, the blob API. But you can only have arrays, and with WebGL typed arrays, you can only have sort of different aliasing views of arrays as either a sequence of int16s or a sequence of 64-bit floats. And then you have to play tricks if you really wanted, let's say, 4 int16s in a row followed by one 64-bit float. You'd have to use 2 array views to view the same piece of memory differently, and you have to trust yourself not to alias the same memory twice and interpret it differently, pun it, essentially. That's a little weird. It's a throwback to Fortran's common block aliased vectors. And I understand why it was done. It was for optimization, and it was the simplest thing they could figure out to do. But Dave Herman's worked on something that is in Harmony, which is binary data, which lets you create generatively new binary data types. You see the struct type constructor. There's also an array type constructor. And you can compose these things. So you can make a triangle that consists of a new array type that you wrote down the description for, which is an array of 3 pixels. And a pixel has heterogeneous information all packed together. And it is packed. It's all on the right machine boundaries. So you can describe what's actually going to the GPU or what's in the memory you're reading from the file, and you don't have to use these crazy aliasing Fortran common block vector things. So that's pretty cool, and that is something I think a lot of people here will make good use of. Somebody asked about a byte type. There's a uint8 there, you see, in the first 3 lines. There's uint16, et cetera. So you have a chance to use these things, not as type annotations for variables, but in these sort of templates for how you view memory through these generative types. One more thing that I think I have to talk about, because I talk about it every talk I give, which is function syntax. I'm still paying for using 8-letter keywords in 1995. I think I took it from awk, and I shouldn't have done that. I should have used FN, then we would have been past this, because probably 2 letters is short enough. And we're using FN in Rust in Mozilla. But it's hard to change. And the idea that you would use Greek lambda, which is an actual Unicode identifier, allowed in ES3 and ES5, or the florin, which Doug Crockford proposed but didn't really champion, those don't really ring true. And there was a proposal to use hash, but I think we want hash for something else. And I've kind of come to realize, to be very frank, that CoffeeScript has already done the right thing. C# has done it. So I'm proposing for the next ECMA meeting, and wish me luck, because it's not a sure thing, that we just standardize this. That what people really want is very sweet, short function syntax without that leading keyword, and the arrow form in CoffeeScript gives us that, and it doesn't do anything else. It doesn't make the function read-only and non-extensible. It doesn't make the function have some different executable semantics, different runtime semantics. It just gives you shorter syntax. And if we want to do those other things, we can add those differently in a composable way. Now, sometimes you might have to parenthesize the body. That's OK. And you might have to write a braced body if you want to write a statement. That's cool, too. So those forms can be supported. With CoffeeScript, you have a new line significant indentation-based block structure programming language. JavaScript can't turn that corner as far as I can tell. It's going to be a bridge too far if we try, especially now. But nothing wrong with curly braces, nothing wrong with parens. And the arrow in the middle is enough. It's a challenge to certain types of parsers, but I think my friend at Apple, Oliver Hunt, who works on JavaScript Core, and I have agreed that we can cope with this. It's very similar to other problems we're parsing already. So there's an example taken straight from Trevor Burnham's CoffeeScript book, adapted to what I hope is the Harmony short function syntax. And it uses the fat arrow to bind this so that you don't have to worry about being called with the wrong context. So all praise to Jeremy for CoffeeScript and the CoffeeScript community. I think we should just pave this cow path. And I'm also proposing that we separate the idea of hoisting and binding from the way you write function expressions, but in a way that cleanly composes. So we lose the need to initialize a variable by assigning it to it or writing an initializer, and instead we just put that left paren right after the name in the binding form, and you get a block hoisted writable or constant function binding. And I think that'll be awesome. There's other things coming that may not make it. That one's still in flight. I want to talk about a few more. People want classes. They really want classes as sugar for prototypal inheritance. There's too much boilerplate. If you don't have them, you get it wrong, you make mistakes. Why should you have to load a library to do this? And yet, in the committee, we seem to get stuck. We want to do something more. We have a different point of view because object-oriented programming has many points of view and many different approaches, different knobs to turn to different settings. I like what CoffeeScript does. I think it's simple and direct, and it maps onto JavaScript, again, efficiently. It's not a general compiler that's doing arbitrary transformations and requiring arbitrary runtime machinery. It's simply desugaring to what people write in JavaScript the hard way. I would like to see that standardized. And this is even a little bit further out. I don't think this has got a proper proposal yet, but I like the coffee use of add as short for this dot. Why not? There are some people who want to use it for other things. When you're down to your last few ASCII punctuators that you can easily type on your Western keyboard, people fight over what the @ sign should mean or what the hash sign should mean. It helps to have things like CoffeeScript out there it isn't overriding. It doesn't tell us what we must do, but it's suggestive. And if we want to pave that cow path, we can. And I'm in favor. I actually blogged about this one. In order to lighten the heavy C syntax, which got heavier from BCPL back in the day when B and then C evolved from BCPL. I don't know if you guys know this, but people talk about D being the next language after C, but it might be P. BCPL was a language Martin Richards did at Cambridge in the 60s. It did not require parens around heads of control flow statements like if conditions. Instead, there was a linking keyword then, or in this proposal, a brace, or a keyword like return. So you don't have to type those parens. If you want to, you can for most forms. And there's more to talk about here that I'll be blogging about again, but this is an idea that I'm going to propose at the upcoming ECMA meeting. And it matters because keystrokes matter, and you see this over time. You see people gravitating toward lighter syntax. You see productivity mattering in the long run, even if it is a small win. And then operators. Everybody wants something like the existential operator in CoffeeScript, the C# question mark operator. There's an assignment form. I think we worked mostly through some proposals from Crockford for div, mod, and mod. I'm proposing isn't based on the egal idea, which is already harmonious. We just haven't figured out the syntax for saying when any value is exactly the same as itself, including nan, which you might know is not double equal or triple equal to itself. It's irreflexive, and there's this weird equivalence class of -0 and +0. Those are treated as double equal and triple equal to each other, which drives some people crazy. So we have is and isn't, we can really finally have true egality, or egal as Henry Baker called it. So those things are not there yet, but I hope they get there. There are some other little fixes that are in flight and some fixes that are already approved, but I'm not going to dwell on them. So what's really going on here is we're trying to get satisfy these goals. And in particular, you want to be a good target for code generators, but code generators are compilers, are apps, and they need libraries, they need large structure, they need modules. So we're trying to serve those in the short run with things like modules and proxies, binary data. And we want to codify de facto standards. We do not want to be inventing things in committee. It's a nightmare. I mean, it's very hard to get Croc and my friends at Google and other people to agree on any new thing. It's much easier to say, here's something people do, it looks good, let's standardize it. So if you guys do good work, we'll standardize it. That's, again, no fear, join the cause. Your uncle JavaScript wants you. And so the word of the day I want to leave you with is transpiler, which is another one of these neologisms, or transcompiler, I suppose, is nicer. But if you have like-level languages, you're not lowering to machine code. This term makes some sense because there are differences between having to write a compiler that generates arbitrary transformations and requires arbitrary runtime machinery versus just what CoffeeScript does, which is to say it's just syntax, it's just JavaScript. There's a big difference, in fact. There's a theoretical computer science difference. So we're working on transpilers. CoffeeScript is an example. There are others. To emulate the new JS.next features on IE8 will require a little bit more than just syntactic sugar. It's going to require a little bit of compilation and some runtime work. But it can be done, and it should be done, and polyfills rock, and everyone can write them. It's not that hard, and Jeremy's going to talk more about that. Plus, I wanted to say, people then say, oh, but I can't debug my primary source. Well, we're working on that. There are proposals, and I think the V8 guys are on board to work on this, to make it so that you can have a concise mapping to the original line number and column number in your primary source. So when you're debugging and planning breakpoints, you're not working on your generated JavaScript, you're working on your CoffeeScript.
Alrighty, thanks, Brendan. And so I'm going to talk about this briefly from the perspective of, CoffeeScript was a little sort of thought experiment as a language from not that long ago, just a little bit over a year ago is when the first commits were done to it, and it was originally written in Ruby, and then eventually when it became fleshed out enough, became self-hoisting and can now actually compile itself. So if you ever try to contribute to it, you're probably going to be very frustrated because as soon as you make a change and compile that, and you do something wrong, you've just broken the compiler, and you can no longer compile the code anymore until you git checkout dot and blow it all away. So Yeah, so there's a very tight feedback loop there. So I think it's sort of at the point where I can assume that most of the folks in the room are at least vaguely familiar with it or have brushed across it, so I'm not going to spend too much time dwelling upon what it actually is. But the general philosophy is to have a little language that compiles into JavaScript and tries to expose the good parts while sweeping the awkward parts under the rug to whatever extent is possible without changing runtime semantics. So it comes from the perspective of someone who spends all day writing JavaScript apps. I work on Document Cloud, and I work on the interactive news team at the New York Times, and do big JavaScript applications where basically it's an empty body tag, and then you have all kinds of UI and models and everything else that gets loaded in as JavaScript. So asking the kinds of what-if questions. What if you don't have to worry about all your semicolons or trailing commas in IE? What if you don't have to wrangle with the prototype chain to get it to do the right thing and have more than one level of inheritance without getting confused? What would the minimalist syntax be for defining a function, or for defining a function where this doesn't change out from underneath your feet depending on how you call it? So the basic slogan of CoffeeScript is it's just JavaScript, and I don't mean this syntactically because it can look very, very different, but semantically, JavaScript already has a truly gorgeous object model, especially when you compare it to other completely object-oriented programming languages like Ruby, where there's a whole lot of complication between classes and instances and meta-classes and modules and how lookups happen. In JavaScript, it's very simple, it's very clear, and you have this sort of flexible programming paradigm composed out of the holy trinity of highly dynamic structure, where all these objects can be changed at runtime and be very polymorphic and get passed to any function. You have flexible objects, both in terms of object literals and in terms of prototypes, being kind of a build-your-own object-oriented programming. And you have first-class functions with closure scope, which, of course, I think we all recognize how crucial they are. But it's worth calling out that things like Node.js are made possible entirely because of how closures work in JavaScript, and having the ability to hand off the closure to the event loop and then come back to the same point in your program after lots of other things have happened in the meantime. So we want to embrace the limitations here of compiling into JavaScript. No interpreter running in JS, no VM, no intercepting calls, no special functions, which is a rule that we fudge a little bit for conciseness. But so this is a different philosophy from other similar languages, and there's a bunch like Move, which makes it safe to extend all of the main core objects with helpful methods, or Objective-J, where for every method call you perform against an Objective-J object, it gets passed through Objective-J message send, which is how they implement method missing. So there's the trade-off, right? You get method missing, but now you have an extra function call for everything that you want to do on an object. So because the semantics of JavaScript are so flexible and so permissive, you can kind of stretch and smudge the language as you see fit. And that makes it an attractive target for compiling. And in fact, you don't even have to compile into JS to compile into JS, in a manner of speaking. Check this out. Here's def.js, which uses some fancy value of tricks to have kind of a Ruby-esque definition syntax with that arrow sign for extending. And here's an even more interesting one. This is a little bit of fab, which, despite what you might think, this is just JavaScript. This is the actual JavaScript parser going through this, and it's syntactically valid. But we're talking about compiling to JS here, not, I think Jed will forgive me for saying abusing the existing JS parser. So compiling to JavaScript, let me just pop out here and switch to TextMate. This is what you might think of when you think of compiling to JavaScript. This is the C Python implementation compiled through mscripten into JavaScript. But and then here's a big list on the CoffeeScript wiki of all kinds of languages, and you might not have realized there was quite so many that target JavaScript as their compilation targets in all these different categories, right? You have things that are similar to JavaScript and add features. You have flavors of Ruby, Python, Java, Lisp, Scheme, OCaml, Haskell, Smalltalk, Basic even, compiling down into JavaScript. And other interesting ones like Haxy, I don't know how you pronounce it, where it's actually a multi-target language. All right. But so given the Python example, let's not go there. Let's not emit a big unreadable block of JavaScript code. Let's take a non-JS language and compile it into plain old, boring JavaScript. So this is some code that the CoffeeScript compiler produced. adding a find function to the scope class, constructor function in this case. So in a perfect world, and hopefully this doesn't look too crazy to you, in a perfect world, which this isn't, but it would compile, CoffeeScript would compile to the same JavaScript you would have written in the first place. That's kind of the thing that we're striving for. Timeless quote from a few hours ago. Dave Herman said, "I don't think anyone should be a compiler. I think the compiler should be a compiler." So CoffeeScript language features are added by trying to take these patterns that come up in JavaScript time and time again and coming up with sort of the simplest, least multiple syntax. So trying to say that there's not going to be more than one way. We're not going to have named functions and functions that are named with variables. We're just going to have one kind of naming a function and find the way to express that clearly. So what kind of language features are we talking about here? We're talking about significant white space. So you're already indenting your code. Why should you have to surround it with braces to say what the structure is? The structure's already there. The big one, and this is actually not just a syntactic change, but a real semantic change, is that in CoffeeScript, to the greatest extent possible, for almost everything except for words that actually can't be expressions, like throw, actually I guess throw can, but continue, break, return, everything's an expression. So even things that are statements in JavaScript, like ifs and try catches and switches, are expressions in CoffeeScript and can be assigned to a value or returned from a function or used as part of a greater expression. There's the bound function literal, where you say, give me a function where this isn't going to change, and it's exactly what this is lexically. We have the class sugar for prototypes. So instead of having to build your constructor function and attach its methods one at a time, because if you assign it to a prototype object, you're going to blow up what the parent was, you have a convenient syntax for defining classes and for calling super, which is always kind of a pain. You have to know the name of your parent. You have to apply the method. So we can determine that because we know what your parent is, because it's part of the class syntax, and we can call that for you. So loops, this gets back to the everything is an expression, right? A loop, what is a loop as an expression? If you try to return a loop or assign a loop to a variable, that's the comprehension of values. You know, every iteration through the loop computes a value, and the array of results is the result of that expression. Destructuring assignment, which is pretty much the same, I think, pretty much the same in Harmony as it is in CoffeeScript, where you can have nested arrays and objects on the left-hand side of your assignment, and it destructures that exact pattern on the right-hand side and pulls those into local variables, which ends up being really handy with modules, because that means that instead of having to, say in Node.js, you want to pull all kinds of utilities off of sys, you're going to require sys and ask for them, you know, puts, or not puts anymore, console, or wait, puts is still on sys, right? And inspect equals require sys.inspect. You can just say object inspect equals require sys, and it's going to pull off that value of the same name, destructuring it. An existential operator, so you don't get into trouble, right? Because we all know that 0 is a perfectly good value for a number to be, and an empty string is a perfectly good string, that you really want to know, does this variable exist or not? Is it null, is it undefined, or does it exist? So the existential operator gives you a convenient way to talk about that. Splats, getting back real arrays, both, again, as in Harmony, with the spread and the rest syntax, so that you can use them in your function definitions to accept a variable number of arguments and have a real array inside the body of your function. And you can also call a function with a few arguments and then passing in a splat that will fill in the rest of the arguments positionally. Default parameters, which are a perennial favorite from folks coming from other scripting languages, where you can default an argument if it's not passed without having to do it at the top of your function body. One kind of fun thing is that CoffeeScript has sort of 3 different ways of writing these block level pieces of text. So there's here docs, which are strings. Lots of people use it for HTML, for better or for worse, where you have a large block of literal text. Here regexes are really nice, where you have a regex where white space doesn't matter, so you can space a really complicated regular expression, you can break it down, space it on the multiple lines, and comment it, what each little piece does. And then also here comments, which are like block comments in JavaScript and work the same way. And then automatic lexical scoping, which is, I think, another sort of semantic change, where there's no var in CoffeeScript. You never leak globals by accident, even if you forget that var I at the beginning of your for loop, which I guess you don't have a for loop, so that's not really an issue. But everything is lexical to the nearest local scope, and so shadowing is forbidden because of that. All right, so I'm going to pop over to TextMate and turn on mirroring and go through a couple of these quickly. All right. There we go. So to give you a bit of a flavor of what the syntax looks like, Here we have a JavaScript function that we all know and love, right? Take a value x, multiply it by itself to get the square. So if we wanted to come up with a minimal syntax for this, what would we do? We'd start by deleting the semicolons, because who needs the semicolons? Right? This is still valid JavaScript. Then we could get rid of the curly braces, because after all, we have the indentation that tells us what's going on. We don't have to use return, because everything's an expression, which means that the value of calling a function is the last thing that it evaluates unless you choose to return early. We don't need the var, because the variable is going to be automatically declared for us. And then finally, let's get rid of that function keyword and say that the input of the function points to the result of the function, right? The input goes to the output, squares a function that takes in x, and it returns x times x. So here we've got valid CoffeeScript. If I compile this right here in the browser, or not the browser I'm talking about, right here in TextMate, it's just hooked up. If you get the TextMate bundle, it's hooked up to Node, and you can do Command B to compile and Command R to run. So this is the result of the JavaScript, and it's hopefully what you'd expect, pretty much what we started with. So those are functions. Literals, JavaScript already has beautiful literals, so arrays and objects are pretty much the same. On objects, it's kind of sort of YAML style if you've used YAML. Indentation can delimit your object structure, so you can leave off the curly braces. You can put them in if you like, and you can leave them off if you like. Commas are also optional because, again, it's white space is significant, so if you have one entry per line, you don't need to do the commas or worry about the trailing comma for IE. And so if we run this code, we're going to log that 14 is elements.silicon. So significant white space, right? Here's our if statement. If today is Tuesday, then it's dysentery day, I'm afraid. Let's see what's going to happen. Yep, indeed, today is Tuesday. So that's your basic significant white space. Comprehensions. So here's our basic for loop. We have an array, a list of A, B, and C, and then we're going to log each letter in that list. And so if we highlight this and we run it, we're going to get A, B, C. Unfortunately, because there's not a common iteration protocol between arrays and objects, right? You have to use for in or go through the length. We have to actually use a keyword to distinguish between the two as to what you're going to compile into. So if we log each name in process, process being the global object, or not the global object, but one of the global objects in Node.js, we're going to get back the list of all of the global keys on the process object. And so those are comprehensions. All right, so now I want to get into a little bit about how everything is an expression in CoffeeScript, even things that would not otherwise be. So we're going to pull inspect off of the sys module from Node. We're going to loop through. This is our regular oops, I need to do the whole bit here. Our regular loop where for I in 1, 2, 3, we're going to log the inspect value of I. But now if we take that exact same for loop and we use it as a value, right? We parenthesize it. We say this is I for I in 1, 2, 3, and we log all of this. Now you see that the result of doing I for I in 1, 2, 3 is the array of each value. So if this was I times I for I in 1, 2, 3, you would get what you'd expect. 1, 4, and 9 being the squares. Even for totally crazy things, right? Like try-catch. You ever wanted to pass directly a try-catch statement, but it's not really a statement, right? It's an expression now, into a function? Well, hey, why not? So let's log trying to call a property on an object that doesn't exist and then saying what the error is with there's a little bit of a string interpolation there. So, and the error is referenced error, missing is not defined. So splats, this should be pretty basic, right? Best actor is a function that takes in one winner, and the rest of the arguments that you pass are going to get combined into the others array. We're going to say who the winner is. We're going to say how many folks are runners up. So we're calling this function passing in 4, and we have the Oscar goes to Jippo Nolan with 3 runners up. Hopefully not too surprising, and pretty much the same as it is in Harmony. Now the existential operator can be used to ask whether a variable exists. If it's not null or undefined, it can also be used inside of dotted accessors to soak up the rest of the chain. So if you've ever tried to deal with an API where you get back a deeply nested JSON object, sometimes you have to keep checking every step of the way. Does this thing exist? Then I can try to access it. Does the next thing exist? Then I can try to access it. So you can use the existential operator in these cases to soak up the rest of the things, and if it does exist, you'll get the value, and if it doesn't, you'll get back undefined instead of a reference error, I believe. Quickly through classes, so some of the shortest example that you can do that demonstrates regular classes and inheritance, right? So In JavaScript, that means constructor functions as the class object and then the prototype chain doing the inheritance. So here we've got a doctor, and when he does the diagnosis, I'm afraid you've died of dysentery. But if we have a lying doctor, extending doctor and overriding the diagnose method, right? This is just like having a parent in your prototype and then overriding the method of the same name so that when you look up the call, it doesn't go up to the prototype chain to find it. The lying doctor says that you've died of old age, which simply isn't true. And if we have an apologetic doctor, we can call super without having to worry about what the parent class is and what the method name is and using call or apply to do it. So I'm terribly sorry you've died of dysentery. To go through destructuring assignment with kind of a fancy example, here we've got a complicated JSON object where we have a sculptor, a painter, and a poet, and the poet's got a name and an address, and the address is an array with 2 lines. And by mirroring the same structure on the left-hand side, we can assign that pattern match to the value of the object and then get back out the variables, right? So we have FT Marinetti lives on Via Roma 42R. And to throw it all together using a sort of a real-world example, if you take a JavaScript function, this is the kind of thing that you can tend to expect about, of course, all of the trailing, bracket, parentheses, semicolon, bracket, parentheses, semicolon get stripped off. And you can use, you don't have to return the values of these inner functions, and you can use things like splats to handle your arguments. So back. That's sort of the whirlwind tour. And there's lots more goodies in there that we didn't have time to go into in depth, but I imagine that a lot of you have already started playing around with it. So BYOJ, build your own JavaScript. So if everyone saw Andrew's talk yesterday, which I hope you did, he really knocked it out of the park, talking about how lots of the features that end up in browsers and end up in the standard are prototyped and implemented in JavaScript first. And a lot of the time, the first implementation doesn't even get things right necessarily, like you mentioned with function.prototype.bind. So it's important that we have a diversity of approaches being tried. So we need more folks fleshing out ideas like bind, trying it out, not just experimentally, but maybe in their production code bases. And we need a tighter feedback loop of getting those ideas into TC39 and into JS in general, into what the browsers are doing. So in terms of ECMAScript 5, right, that we had about a year and a half ago, is that right? Object.defined property kind of exists because of the how do we extend core object problem posed by Prototype.js and others. UseStrict exists because as a community, we've agreed to try and avoid certain features that end up doing more harm than good. And the JSON object exists because it was prototyped in JS first, implemented, then moved into browsers natively, then moved into the standard. The array extras, map, reduce, filter, every, sum, were done in JS first, and then moved into browsers and into the spec. And all of those things, aren't exactly rocket science. So I'm hoping that we'll be able to get into it to give you the encouragement to scratch your own itches with JS, if you have any. And when you walk out of the room this afternoon, hopefully feel like it's something that you could take on if you had the desire to. And so to keep up in dialogue with some of the other talks, with all due respect to Rebecca Murphy, who knocked it out of the park downstairs this afternoon, yes, we need more seedling miles and we need more signposts, but if we're real about sort of the economics of it, this is all open source code. It's not a zero-sum game. The more you produce, the more you give away, the more you have. And we can have better signposts and also have a diverse, thriving marketplace of libraries and language dialects, and it's not an either-or proposition. And also from a purely selfish perspective, by building your own JavaScript and targeting JavaScript as your compilation target, hey presto, your code runs everywhere. It runs in the browser, it runs on the server, you can build web apps with it, you can script Photoshop with it, and simply by virtue of running on V8 or TraceMonkey, it's probably one of the fastest dynamic languages in existence. And the oldest saying in the book for literature is also just the same for writing code, right? You have to throw a lot of crap at the wall if you want to see what sticks. And just between me and you here at JSConf, I can tell you that CoffeeScript has been an absolute magnet for throwing crap at the wall. Some days it feels like everyone who's ever seen a programming language feature that's not already in JavaScript has opened a CoffeeScript ticket trying to add it, right? Immutability, point-free style, macros, fibers, different continuations, single static assignment, yield, code annotations, static typing, semi-static typing, contracts, all that stuff has been attempted or proposed with the patch. And that's great. CoffeeScript isn't going to be the arena for that stuff because we have to try to stick to the sort of philosophy of doing the straightforward JavaScript translation. So even if it's a brilliant idea, if it doesn't compile straightforwardly into JavaScript, it's not going to go into CoffeeScript. But there should be other JS languages, other compiled to JS languages that explore these things. How far can you go with contracts if you want to take things in that direction? How well do they work in the context of a web app? How well do they work in the context of a Node app? How far can we go with asynchronous syntax built into the language? Can we get rid of the error, comma, pattern in callbacks if we have something at the language level? How much does it help in a real-world application? So with the goal of making it easier for you to get started with doing your own compiled to JS languages, CoffeeScript source code is all annotated to try to make it easier to use it as a starting point should you need one. So that's, let me grab back the browser, and there we go. Pull it on over. So the CoffeeScript code base, as I mentioned, is annotated. Here, for example, is the source code to the lexical scope object, which tells you what variables in the current scope of your function, and if it's also present in a higher scope, and everything's kind of explained here if you want to use this as a starting point. And the guts of the compiler are also exposed in a way. So let me drag. Actually, we'll turn on mirroring for a sec. We'll just bounce back and forth here. So here we've got the command line, and I've got the CoffeeScript compiler going on here. Let's open up a test file. Let's put in our friendly function, right? Square is a function that takes in x, and it returns x times x, and save that. So if I run bin-coffee print test.coffee, I'm going to get back my code that I would expect, right, that we saw earlier in TextMate, but I can also ask for the AST. So here's the abstract syntax tree of what's going on in that assignment, right? We have our main block of code. There's an assignment at the top level. The value is square, which is the identifier, being assigned to a block of code, and the code takes one parameter, which is called x, and then its body is a block of code, where the expression in the body is an operation, right? Multiplication, that it takes two values, both of which are x. So you can see the AST broken down like that. And if you require the CoffeeScript compiler in your JavaScript app, in the browser or in Node, and you do CoffeeScript.nodes, this is the tree of nodes you'll get back, is basically this, is just being printed out. And you can also get back the tokens. So if we want to go back a step further, right, from the source code to the AST back to the tokens, you can do dash, I should probably do the long form here, right, dash dash tokens. That was dash dash nodes previously. So here are the tokens, right? Tagging things as identifiers, symbols, the start of a parameter, identifiers, indentation, right? You can see how indentation becomes a token here, and all the operators. So that's what gets fed into the parser. Alrighty. Mirroring and back into Keynote. So that's the quick overview. And for folks who aren't familiar with how these sorts of compilers work, especially in terms of JavaScript, I know it can feel daunting to get started. Full disclosure, I have no formal background in languages or compilers or even computer science, really. So it's not rocket science. The basic idea is you take your source file, you lex it, which means that you go through and sort of from left to right, and for all the parts of speech that you see, this is a symbol, this is an identifier, this is a string, this is a number, this is a parentheses. In our case, this is indentation. You just tag what that is. And then in CoffeeScript, there's a step after that where we rewrite the token stream that I'll get into in a moment. But basically, you take your list of tokens, which is just a big array, or whatever your data structure is, but probably a big array of tokens, and you pass it to a parser, which is often generated for you by a parser generator or handwritten, depending on how you want to do it, where you set up the rules. You say, if you see, arrow and then indentation, that means function, and I'm going to make the function node and pass that back to you. If I see something plus something else, that's addition, that's an operation, and I'm going to make the operation node and say that's an addition and pass that back. So that's what this grammar is here, defining, I guess. So there's a block of code and what the rules are, right? It can be an indent outdent or an indent body outdent, body being something else that's defined, right? There's an expression at the top, all the different kinds of things that an expression can be. Identifiers are a symbol, an alphanumeric thing can be either a number or a string, and so on. Basically define the rules for what your grammar is. When the parser runs on your tokens, it gives you back the abstract syntax tree of nodes. And this is all just in terms of CoffeeScript's case. And then we walk the syntax tree and we turn the nodes into JavaScript. So they say, given that I'm an identifier, my name is X, what is that in JavaScript? It's just X written out, right? I'm a string, and I have the value of hello world. I'm going to put quotes around that, and that's my value. I'm a function. I know how to indent myself, and all that kind of stuff. So it's okay to cheat if you're doing a sort of little language experiment, right? CoffeeScript has lots of optional syntax. If it's not ambiguous, you can leave the parentheses off of method calls, you can leave the commas out of lists of things, you can leave the brackets off of object literals, and you can even leave the indentation out of the significant indentation if you use then as the keyword. So all this optional syntax makes things really hard to parse if you don't cheat. So if we look at how another language with a decent amount of optional syntax handles things, if you ever looked at Ruby's parse.y file, it's 10,492, last time I checked, lines of really, really hairy sort of yak and manual manipulation of the parse state code. And we don't want to get into that kind of madness, so the CoffeeScript parser is actually just about 600 lines of our JSON grammar rules with no special callbacks or anything, and lots of comments in those 600 lines. But we're cheating because the parser isn't handling any of the ambiguity. It's all disambiguated ahead of time. So there's that rewriting step that I mentioned in between the lexer and the parser, where it scans over the token stream that the lexer has produced, sort of very simple-mindedly, and it disambiguates everything that would otherwise be ambiguous to the parser. If you've ever wrestled with it, anything that would cause sort of unsolvable shift-reduce errors, we want to disambiguate ahead of time so the parser knows what's going on. So that means if you're missing a pair of parentheses because you've said alert hello world without doing the parentheses, it's going to insert them for you. If you're missing braces around your object literal, it's going to insert those for you to say where the object literal starts and it ends. If you use then instead of indentation, it's going to insert the explicit indentation for you. So that's actually that's the secret sauce that makes everything happen, and actually gives us more parsing flexibility than some languages like Ruby, where Ruby's parser will get confused if you try to pass a block without, or sorry, if you try to pass a hash without parentheses, right? It thinks that it could be a block and doesn't really know what to do with it. But if you disambiguate that ahead of time and you decide what the actual call is, you can make that sort of stuff possible. So it can feel daunting to get started working on a little language that compiles to JS, but there's lots of support groups out there, right? Lots of people have done libraries to help you do little languages for JavaScript. JSON is what CoffeeScript uses to generate its parser. It gives you bottom-up parse tables. If you care about this sort of thing, it's LALR1 in most cases, and in our case, that's what we're using, but also has modes for LR0, SLR1, and LR1. Which probably don't need to get into. But it's those kinds of rules that you saw earlier, where you're saying what exactly the larger piece is constructed of, right? An operation is an expression, the time symbol, another expression, and that's an operation, and it sort of builds up from there. And if peg parsers are more your thing, there's good options there as well. There's peg.js and ometa. They're a bit slower than what you'd get out of something like JSON, but you can do sort of more flexible things with them. And a whole bunch of other good projects to get your hands into. And remember that gigantic list of languages that compile into JS? Most of those are on GitHub. Most of them have their source available for you to browse through. So that brings us to the end here. And if you've ever found something that has been lacking in JavaScript as you've used it, I'd like to think that you should be fixing it ideally in public, ideally through open source, right? ECMAScript is at the point right now of trying to decide what is and is not harmonious with the existing body of JavaScript, what makes it into harmony and what doesn't. And the best way to demonstrate a harmonious feature or change is to have something that's already been working and demonstrated in real-world code. So if you've ever been afraid to work on something languagey, don't be, right? It's all just code. If you're comfortable designing a nice API for your JavaScript library, you should feel comfortable designing a nice syntax. If you get stuck, you can cheat. Don't wait for browsers to give you the language that you want. Don't wait for ECMA International to give you the language that you want. You can give yourself the language that you want right now. And I think that this is kind of important above and beyond just JavaScript, right? Because JavaScript is too important of a thing to fuck around with, right? It's too important to be left to the experts. And with all due respect and credit to Brendan and the rest of the TC39 committee, right? The web is the most important cultural artifact of our time, and JavaScript is kind of its pulse. And we can't afford to let it stagnate for another decade. We can't afford to let a corporation tell us how it's going to go. And JavaScript needs your ideas, your libraries, your languages, and I look forward to seeing more of them in the coming year.
Amen.
Thanks. Yeah. Cheers. Assuming we have time for some questions. Yeah. Yeah. No, it definitely gets you into trouble. So most of the regressions and bugs that we end up dealing with are things that happen in the rewriter where we can't tell exactly what's going on. So I won't argue with Aaron. It's a bad idea. You shouldn't do it. But like I said, it's cheating, and it lets us have a lot of the optional syntax that we do. But you wouldn't want to recommend it for something more industrial strength. If you're asking if there's tests for the language spec, there's a whole bunch of tests for all the different features, which basically just assert that the value of the thing in CoffeeScript is what you'd expect it to be in JavaScript. So we run all those all the time. Those are written in CoffeeScript, right? It's just a list of things to write. Make an array, put all this stuff in it. Make it in this crazy way with indentation. Make sure that you get back out the things you expect. Fortunately, it's all running on V8, so it takes like 0.05 seconds to run, all of the tests. There's no unit testing things built into the language itself, if that's what you were asking. No, but you have that, right? So again, we're not trying to add anything to the runtime, right? So we don't want to add any functions that aren't already in JavaScript. We want to have it, whatever is on the platform that you're running your JavaScript on, that's what you get. So if you run it on Node, you get assert. If you run it in the browser, you get console.assert maybe, or whatever the syntax is. Why did we decide not to make it a superset of JavaScript? Yeah. So I think that there's already a lot of languages that do that or that try to do that well. I guess Objective-J being an example of one of them, where it is a strict superset and every bit of valid JavaScript, or at least most of it, is also valid Objective-J. Is that not correct?
Not sure.
Not sure? All right. So I think because it's already been done and because that's not really the goal here, right? So the goal here is to do that thing where you say, here's a function. What's the shortest, most concise possible way that we could write that and get across exactly what the meaning is in JavaScript without having to type function, open paren, blah, 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 close paren, semicolon.
So CoffeeScript is runtime compatible, so you can interoperate at the library level. You can have script tags in JavaScript interact with CoffeeScript. That's the important thing. People new to a language might see it all as one smear, but there's syntax and there's semantics, and they really are separate things.
Right, yeah, so I guess that's the more important interoperability maybe to be argued, right? You can't copy and paste code from one into the other, but you can use a JavaScript library just as if it were written in CoffeeScript and vice versa. If you're using something like React.js, you might not even know that it was written in CoffeeScript originally, and you'd be able to use it just the same.
More questions?
If we want to get to the bar, that's got to be the last one.
All right.
All right.
Thanks, guys.
Great.
Did you remember the baby?
Oh no.